these are the notes that I took that I would have given in class for slope and rate of change. So the first thing you're going to do is Cornell your notes. And let's see, this is 3-1, slope and rate of change. And we need your essential question, which is going to be, how is slope related to unit rate? Okay, and then you have your line for the side. Okay, so first you need to remember that slope, which we use an M to represent, is the rate of change which we always abbreviate ROC, or you may have, last year called it CROC, CROC. I've seen that, constant rate of change. Okay, or the unit rate. So that's how they're related. They're the same thing. And then we're going to add here for a linear function. Okay, so you have to have a line before you can find the slope. Okay, move this up. Alrighty, so remember that to find the rate of change, or the slope, or the unit rate, or the constant rate of change, we compare the vertical change to the horizontal change. So you can find the slope of any piece of a graph between any 2 points. As long as you have like a line segment there, you can find the slope. Oops. And so slope, actually, you may have talked about in science, when you have a graph and you're trying to find the average rate of speed, that's slope, because you're finding the change in y, change in my distance, over the change in x, over the change in time, and that will give you your speed. Okay, so this is important. We'll write that a lot. Okay, so let's talk about how to do that with a table, a graph, and then 2 points. Okay, so table. Okay, so here's one example. We're going to do 2 different examples, x and y. So x is -1, 0, 1, and 2. And y is 30, 20, 10, and 0. So the change in y looks like y is decreasing by 10 every time x is increasing by 1. So I know I have a linear function because you have this constant rate of change going on, because every time I compare the change in y to the change in x, I'm getting the same answer. So let me do that here. So m is the change in y over the change in x, which is -10 over 1, which we can just write as -10. That's your slope. Okay, that is a very steep downhill slope. Okay. So let's look at another example of a table. X and y. Okay, let's do y is 6, 12, 15, and x is -2, 2, and 4. Okay, let's see how this one works. So the change in y here is plus 6, and here is plus 3. Okay, so right now you cannot say that this is not linear, that might have a constant rate of change, because sometimes they make the table jump around so it doesn't go each time x goes up by. So you have to look at the change in x, compare the change in y to the change in x to see if it's constant. So the change in x, that's plus 4. Oops, my goodness, hang on. I have to move over. I got too close to the other side. Plus 4. And this is plus 2. So when I look at my change in x, or change in y over change in x, no matter which 2 points I choose, it's going to still be constant. So it's 6 over 4. Or if I use the other 2 points, I have 3 over 2, and those are equal. Oops, 2. There we go. So my slope is 3/2. Leave it as a fraction, please. Do not tell me 1.5. Slope we want is a fraction because it means something. The numerator is the change in y. The denominator is the change in x. If you just write 1.5, you kind of lose that sort of feeling about it. So leave them as fractions. Do not change them. Unless they're a fraction, like the first example with 1 in the denominator, then you can just go ahead and write the integer answer. That's fine. Okay, so now we have graph. Let's talk about the graph. Okay, so you're still doing Cornell notes there. All right, in the graph, let's draw a graph first. There's my coordinate plane, x, y. So my graph is going to do this. Okay, so let's say this is 2 and this is 3. So this will be -3 and that'll be -2. Okay, so the first thing you're going to do is pick 2 points on your line. And hang on a minute. This is not right. I'm going to pick this point here. And I want that to be, well, it looks more like 2. I'm going to make it 3 anyway. And then over here, I'm going to pick this point, okay, which is going to be -2, -3. Okay. All right, so I'm going to do change in y over change in x. So let me move up. Slope is change in y over change in x. But on a graph, we call it, since the y value is vertical, we call that the rise. And the x value is horizontal, we call that the run. So you count the distance vertically, you count the distance horizontally, that's your change in y over change in x. So, back to my graph. From this point here to here, that's from -3 to +3. That's a distance of 6. So 6 over, and from here to here, that's a distance of 4. From -2 to +2 is 4. So you are going to simplify that. So your slope is 3 over 2. Okay. The other way you could do it is pull your points off your graph, although I think it's, usually we just count it. that's what I tend to do. But if you're not sure, you can always pull your points off. And let's see, our first point was 2, 2, 3. And our second point was -2, -3. So our change in y was +6, and our change in x is +4. So you could do it that way if you're not sure about the graph. And make sure when you're doing the rise over run, though, you do look at the interval in the graph. And so if each interval mark is going by 10, make sure you put the slope down right. And you call it, like, for example, 2 or 20 instead of 2. Okay, let's get another page and do slope between 2 points. Okay, so let's make it match here. Okay. All right, so slope between 2 points. Okay, so 2 points. Okay, so these ones are going to give you, find the slope of the line between like -1, 0. So find the slope of the line between -1, 0 and 3, -2. Okay, so if you look on your reference chart, you will see the slope formula that says this. Only, not in color, but I'm going to color code it. So you find the difference in the y's, which is what you do when you count the rise. You actually are subtracting to find that difference over the difference in the x's, and that's going to give you the same thing, change in y over change in x. Okay, so the first thing you're going to do is write your formula down, like I did. Let's go back and label your points. Oops. No. There we go. Okay, so I'm going to call this point x1, y1, because it's my first point, and this point x2, y2, because it's my second point. And then I'm just going to substitute that into my formula here. So m equals y2 is -2, y1 is 0, x2 is 3 minus x1 is -1. Okay, so you have to be careful about integer rules here. So if you're not sure, use a calculator. -2 minus 0 is -2. 3 minus -1 is the same thing as 3 plus 1, because those two negatives make a positive. So 3 plus 1 is 4. Simplify, we get -1/2 for your slope. Okay, so if you watch the video Slope Dude, and if you didn't watch the Khan Academy videos, that's fine, but definitely watch Slope Dude video. Let's summarize what that says here on the next page. So in the slope, it kind of reminds you that there are 4 different kinds of slope. So you have a positive slope, and they talk about a guy skiing, and he's tired, so he goes puff, puff, positive. Then he gets to the top and he comes downhill, which is fun. So that's nice, negative. Then he gets to the flat part and he says this is 0 fun. When you have this horizontal line, if you try to do the change in y, it's not changing because y is the same for every single point on a horizontal line. So you get change in y 0 over whatever your change in x is, depending on what 2 points you pick, say 4. Well, that's going to equal 0 every time, okay? And then he gets to the edge of a cliff, and he's not paying attention, so he goes off and he yells, undefined. Okay, so this is undefined. So when you're trying to find the slope, especially if you have a graph, you can tell whether it's positive or negative pretty easily. The two you have to get straight is, one, is it 0? When is it undefined? So undefined is a vertical line, which isn't even a function, so you can't find the slope because you need a linear function to find slope. So the way the rise over run or change in y over change in x works, you're going to have no change in y, or x rather, because on a vertical line, every single coordinate is 0 for x, and y changes. So y might change. You might pick 2 points, and you see you have a change of maybe 6. When you try to do the change in x, you're not going left or right at all, so your change is 0. You cannot have 0 in the denominator. That's what we call undefined. Okay, so that does not equal 0, so don't tell me that. Okay, so you can see positive, negative, and then 0, and undefined. Okay, let's try an example. Let me give you an example between 2 points. And this I would put on the left-hand side, but, they're your notes. Okay, let's see. I'm going to write this down. You're going to pause it and figure it out, and then you're going to start the video again to see if you got it right. Between, let's do 4, 3, and -2, -1. Okay, so pause the video. Okay, so we're back. Let's see how you did. We're going to label, I'm going to label this so I can keep track of them. But really, all you're doing is subtracting the y's in the numerator and the x in the denominator in the same order you subtracted the y's. Okay. Alrighty, so slope is, I'm writing down the formula again, so I remember. So I would suggest you do that so you can keep track. It makes it a little easier to keep track of where the negative signs are, which is subtraction. What is negative? Okay, so y2 is -1 minus y1 is 3. x2 is -2 minus x1 is 4. That is going to give me, in the numerator, -1 minus 3 is -4. -2 minus 4 is -6. And that's going to give me negative divided by negative is positive. So when I simplify it, I'm going to be getting positive 2/3. Okay? You can take these 2 points, go with that. You can take these 2 points and do it in a table if you want to. You're going to need to use this formula. You're going to see it a little bit later in this chapter again. But if you're not sure, if you have a lot of negatives maybe, you can put this in a table. Okay. Oh my goodness. Okay. So 4, 3, and -2, 1. So 4, 3, -2, 1. And then you can do change in y from 3 to 1 is that? Oh, it's -1. Wait, that's not working. Okay, 3 to -1 is -4. 4 to -2 is -6. So you get -4 over -6, which, again, is 2/3. So you can always organize it in a table. You just want to make sure when you're doing this formula, that's an ordered pair, -2, -1, and that's your other ordered pair, 4, 3. Okay.